link in the chat again, just in case. You can go here, this green code button, download zip, and then extract those files to somewhere easy to find. Recheck once you have it. So many of these open. So here's mine, UBC AceNet Python main. So what we did is we prepared these notebook files that have explanations and things while also letting you run code. So we'll be working through the day one notebook, which now hopefully everybody has. Let me check again. Yeah, so if you haven't downloaded it, please do so. So yes, I recommend moving it to the desktop just because that's an easy place to find it. So once you have this downloaded, the next thing we'll do is we'll launch Anaconda Navigator, which everyone should have received instructions for how to download. So I can search on my computer Anaconda, and there's a few different Anaconda things, but I will open the Navigator. So I'll search for Anaconda Navigator, click to open it. Usually takes a second to actually open up, but once it does, we'll see what it looks like. There we go. Of course, at any point, if during this initial setup part, if you're stuck, you can toss up a red X or say something in the chat to let us know that you need help. It was really slow for me today. Maybe I'll open it a different way. Okay, I lied. I'm not going to use Anaconda Lab Navigator. I'm going to use Anaconda Prompt because it seems like this doesn't want to open for me. Okay, never mind. It is opening for me. Okay, so this message, they want me to sign in for AI coding help. I don't need to do that. So here we are. I'm presented with all my different options and programs that I can choose from that all came from the Anaconda install. So what I want to do is I want to open Jupyter Lab, not to be confused with Notebook. We want Jupyter Lab, and that'll open Jupyter Lab in your browser. And that's what we'll be working with for the rest of this workshop. So if you're able to launch Jupyter Lab, I'll clear the feedback. If the person that has a red X, can you message a helper or let us know what the trouble is that you're having? I'll clear the feedback, so I'll launch Jupyter Lab now, and it'll open in my browser. There we go. I can't see where the tab is because it's blocked by Zoom. So if everybody is able to open Jupyter Lab, can you give me a green check mark? It is being really slow. Anaconda prompt does need to stay open. Yeah. Okay, here we go. They opened. I don't know why this is being so really slow. I was working with this. Okay, here we go. This is what it should look like when you first open Jupyter Lab. So does everybody see something similar to this? When we launch Jupyter Lab for the first time, we see the launcher, which is this main area here that provides us with a few options on what we can do next. I'll increase my zoom on here a bit so it's easier to see. So we can start a brand new notebook. We could open a terminal. We could start a text file, whatever we want, really. And so up here, if you want to work with multiple notebooks or some combination of notebooks and a terminal, we'll have tabs up here. And this top menu, we have options for file, edit, view, run, settings. And then on the left here, that's pretty important. We have a mini file explorer. And so this file explorer comes in handy because right now we're going to use it to find the folder that you just extracted and find the day one notebook, which will open in Jupyter Lab. So I know I put it on my desktop, so I know where to find my folder that I just downloaded and extracted. So I need you to find yours. And this menu on the side with the files might be collapsed. If you don't see it, there's a little file folder icon on the side here. If you click that, it'll open up. Desktop, so I can double click on desktop, and here I have UBC, AceNet, Python main. I can double click that, and I see my Python day one. Click that to open. And now I've opened my notebook. Yeah, so another option, if you don't have Anaconda downloaded, you can also use Google Colab, which, oh, I don't want to click on the tab because then I won't be able to get back to where. Here we go. All this. So if you open Google Colab, that's another option for you. If you don't have time to download Anaconda or if Anaconda's being too slow, this is what it looks like when you open a fresh Colab instance. You can go upload, browse, and then find the notebook through your file explorer and open it that way. And the interfaces are almost the exact same. So you'll still be able to follow along if you do this. I will minimize that. Oh, and go back to, here we go. Right. So in a notebook that we already have pre-prepared, so there's already text and code in here, we work in what's called cells, which can contain either code that you can run or markdown formatted text. So what we have here, this cell right here, this is text, and then here we have a code cell that we can eventually fill in. So if you click once on a cell, you'll see there's some icons that show up over on the right. So you can duplicate the cell, you can move it up or down in the order of cells that are there. You can also insert a cell above or below or delete it. So what we'll do, everybody has a notebook open that they're able to use. If not, a helper can help you. Yeah, if you want to use Colab, you go upload. This is what it'll look like when you first open Colab. Upload, browse, and then you find the file on your file explorer. That you would have downloaded from GitHub. So what I'll do is I'll keep going. So we'll start by talking about one of the most powerful tools in Python, well, and in programming in general, and those are variables. So you can think of a variable like a storage box where you can put information that you might want to use later. And so this is how we make computers remember things for us. So if you've done any programming, in any other language, essentially. The concept is the same, where variables store information. And so the first thing we'll do in our notebook is we'll do just some quick math. And so we can get Python to evaluate a simple math expression. So I can write an expression in this cell, this first cell right here, that has just a comment that says your code here. And so the comment is indicated by the hashtag or number sign at the start. So that means whatever text comes after that number sign won't get run by Python. And so you'll see a bunch of these empty code blocks throughout the notebook, and that's where we'll be writing our code today. And so you can type whatever you want in a comment, and the Python interpreter will skip it when it goes to run your cell or whatever code you actually have written. So for all these cells that are there waiting for you, I can click or double click on them to edit. I can type what I want, and then I can press Shift plus Enter to run them. So for my first little bit, I'll write a math expression. I'll write 2 plus 5 times 8. And now I've separated all of these by spaces just to make things easier for me to look at. And then when I want to run this cell, I want to execute what I've typed, I can hold Shift on my keyboard and hit Enter. That will give me my answer. You'll also notice there's a little play button at the top here, and that can also be used to run the cell, but for the most part, the easiest way is always to hit Shift Enter when you're entering these. So I can also go back into the same cell. I can click back into it, edit it, rerun it, Shift Enter. I change that 8 to a 9, and I can see what my answer will be. I can go back again and again, edit it, Shift Enter. You'll also notice that there's a number next to the cell where you ran the code, and that means that it finished running successfully. We can also tell that it ran successfully because we did indeed get a number that is a correct output, but it's really common to run into problems if, say, you didn't, say you had left a bracket open and so the cell isn't able to run properly. You'll see what happens probably later if a cell starts to hang, because if a cell is hanging and it doesn't complete its execution, you won't be able to run anything else in your notebook. But this number on the side here means that we're good. And so continually using Python as a calculator, that can be handy if, we didn't all have phones and calculators all over the place. But so this isn't a very exciting thing to do with Python. And as you probably noticed, every single time we edited the cell and reran a new math question, we also lost whatever our previous answer was. So one of the things that makes programming powerful is the ability to store this result, or any other data really, and use it again whenever we need it. And that's where variables come in. So a variable is a name that refers to a value. So in the previous example, we saw we used Python as a calculator, but the results of these computations are lost after we perform our operations. So if we want to save and reuse any value in a larger piece of code, we need to make sure that we save the results so we can access them again. And so variables are names that we associate with a memory location in computers. So variables are not values themselves, but they point to somewhere on the computer where the actual value is stored. So now what we can do is we can set a variable, and we'll do this by first typing the variable name, a variable name, then an equal sign, followed by the value we want to assign that variable. So I'll create a variable. Let's say weight underscore kilograms underscore kg equals, and we'll say 60. And again, you don't technically have to add spaces in between your equal sign and everything else. So we have our variable name, equal sign, and then the value we're assigning it. But it is good practice because it makes it easier for you to read when it's appropriately spaced. All right, so having spaces is usually part of the official recommendation in the Python style guide, but it's been a while So now what we'll do, I'll hit enter and I will call the variable. Well, actually first I'll hit shift enter. And so we've executed this cell that's assigning 60 to the value of 60 to the variable weight underscore kilograms. And you'll notice that this time there's no actual output. So what we'll need to do is we actually have to call the variable. And this is something that we could do specifically in Jupyter Lab, which is very convenient. If I want to call the variable, I can just type its name on its own. And so this should print what that value is. So I went back into the same cell, called my variable name, and now I'll shift enter, and it prints the value of weight underscore kilograms, which is 60. So now Python will remember that weight underscore kg equals 60. And so instead of doing math all over again or writing the number repeatedly, we just need to use, we can call that variable whenever we need it. So some pointers, a few rules for naming variables. They can use letters, digits, and underscores, but the name can't start with a digit or a number. And then variable names are also case sensitive. So if we had lowercase weight and capital W weight, those would be two different values according to Python. So just some examples, weight 0 would be a valid variable name, but 0 weight wouldn't be. And then weight underscore kilograms, like this, all lowercase, is different than weight underscore kg. If I were to, let me see, I'll use this and I'll insert a cell on top of this text cell right here by using it's a square with a plus on top. That should have one on top. Yes. I could try, if I tried to call weight underscore kg like this with a capital W, shift enter, it tells me I got something wrong because it says name error, name weight underscore kg is not defined. So it's saying there's something wrong with this name. I changed it, went back in, changed that to a lowercase w, and now it's our same variable. Okay. So, when I see there's lots of activity in the chat, if something needs my attention, Tanya will tell me. And of course, any other questions that you have, pop them in the chat too. All right. So data types with Python. All we've done so far is use some numbers. So Python can work with different types of data. Okay, it says 3 here, but there's 4. 4 of the most common types are, we have integers, which are whole numbers like 1, 2, 100. They essentially don't have a decimal point. Floating point numbers, so numbers that do have decimals, like 2.5, 60.3, etc. Strings, so if you want to store text or if you want to save numbers as text instead of their actual values. And then another important type is our Booleans, which are true or false values. So, for example, let's say we wanted to store a patient's weight. And so if the weight is exactly 60 kilograms, we can use an integer. So I'll go into this cell block here. And I mean, we kind of just did this, weight underscore kg equals 60. So I can hit shift enter and run that, even though we already have a weight underscore kg variable saved. So, but if we wanted to be more precise and say 60.3 kilograms, we could use a floating point number instead. So I'll go into my next block, enter, and we'll set weight underscore kg to be equal to 60.3 instead. Now I can shift enter to execute that. So now weight underscore kg is a variable that stores a decimal number or a float. And so it could represent any weight in kilograms, which we might use later for calculations or comparisons. More on those very soon. And so when you're setting a variable like this, we don't have to tell Python that we want this to save as a float. By inputting a number that has a decimal point, it will know that it's a float because integers don't have decimals. We can also store text by setting the variable to a string. And so to do that, we use double quotation marks. So in this one here, I can type name. I'll set a new variable, name equals, and we want to use double quotation marks. And let's say name equals Sarah Park. And I make sure I finish that double quote because that's one of the easiest mistakes to do in Python. So Park in double quotes, shift, enter. And now that variable is stored. Strings can store text data, which can be useful for labeling or adding metadata. There's a lot of useful reasons to include strings in your programming. And then finally, scroll down a bit, we have Booleans, which are used to represent true or false values. And so these are really helpful in logical operations or conditions, checking conditions. Say we wanted to check if someone is tall or not according to some condition. We can first start in this code block here. We can set a variable for height. So I can type height underscore cm equals 165. I'll go enter. Now what we want to do, we want to check if that height is greater than, I don't know, 180 centimeters. That's a barrier for being tall. It's almost 6 foot. We'll ask is underscore tall equals height, height underscore cm, and then greater than 180. So we have this variable that should give us a Boolean asking if height underscore centimeters is greater than 180. And now we can call that is tall variable. And before we run this, this is a straightforward enough example that we can look at what we wrote and know what the answer should be. 165 is less than 180. So I'm expecting that this result is going to give me false. Go shift enter to run this block. And it does indeed tell me that it's false. So with this variable, we could decide whether we wanted to apply certain calculations or adjustments based on the height. Maybe this is part of a larger script where if the height value is high enough, then there's more calculations to do, or if the value is too small, it gets thrown out. There's a lot of possibilities that open up, and there's a lot you're able to control using what seems like really simple operations, like checking if one number is bigger than another. It lets us write a lot cleaner and more conditional code. And so it lets things become a lot more automatic, which is what we want when we're programming, because we want a program to make our lives easier. All right. So is everybody still with me? Give me a green check mark if you're good up to now. I wanted to go a bit slower in this beginning section while everybody's still getting sorted out, but I think yeah, so far we've talked about a couple different data types and how to set variables. So variables, we type the name and then use the equal sign to give it a value. For numbers, we can just type the number, but then if you want to use strings or text, then you have to enclose that text in double quotes. And the last thing we just did was Booleans, where you can check if a condition is true or false. And we'll talk more about Booleans and conditionals towards the end of this. Yeah, we'll talk about Booleans and conditional statements in more detail a little later. We should, yeah, no worries. All right. So now we'll do some more operations with variables. So addition is one of the simplest operations we can do, which we've already seen a little bit of. If you want to increase a value, then you add to it with the plus sign. So let's say I'll go into this cell here. We have a population measurement of 20,000 people. So I can write population equals 20,000. That's the right number of zeros. And we want to add 5,000 more. So I want to have a new variable, I'll use pop for short. New pop equals population plus 5,000. We have our original population set to 20,000. And then we have the new pop variable equal to whatever the value of that population variable is plus 5,000. I'll hit enter again, and I'll call the variable new underscore pop. And then we'll shift enter to see what the value is. Good question about what if we can add a comma in that 20,000. I don't think that'll work because I don't think Python is expected. Commas have their own use in Python. So it makes it hard for long numbers. I could try it. I can do this. And now it tells me there's something wrong because it can't actually read this population because I've split it up. Right. So there's lots of other operations that are just as simple. So if we wanted to, let's say we had a temperature value that we wanted to double, I could go under here, set temperature equals 8, enter. I want to double the temperature, so I'll save a variable double underscore temp equals, we can do our temperature variable, and to multiply we use an asterisk. Temperature times 2. Variable double underscore temp and see what I get, which should be 16. Nice. Division works the same way. We can divide one of these variables that we've already set. So in a lot of these, we've been creating a variable in the same cell and then using it. We've been creating a variable and using that variable in that same cell. But because we've run, say for this cell here, we have a population variable saved as 20,000. We can use it again in a later cell as long as this cell has been run. So when I go to divide, I already have my population variable saved. So I want to divide that value of population by 100. So I can say pop, short for population underscore ratio equals population divided by 100. And so that should divide the value of the population variable by 100. Hit enter. All that ratio variable. Shift enter to run. And it gives me my ratio. So the last thing we can do, Python can also handle exponents. So if you want to square things or some other use for exponents. Let me scroll down a little bit. So if we want to find out what the population squared is, we can do that too. I can write squared underscore pop for population equals, we'll do that same population variable because every time we're doing these, we haven't changed our population variable at all. Every time we do an operation on the population variable, we're saving it to a new variable name. So this population variable remains unchanged through all of our work that we've been doing. Squared pop equals population, and you might be tempted to use the caret symbol, but to do exponents in Python, you do two asterisks together with no spaces between them. So population asterisk asterisk 2, that'll square it for us. So now I can do squared underscore pop, call that variable, shift, enter. This is a not very nicely formatted number. But alas. So yeah, using exponents, that's useful for, calculating things, squared distances, other exponential relationships, half-lives, exponential decay of radioactive elements. There's lots of reasons or applications for using exponents. All right. Is everybody okay up to there as well? I keep an eye on the time. So great questions in the chat, but the helpers are doing a great job answering them all, from what I can tell. Keep them coming. Okay. So now let's talk about strings. So with strings, one common thing that we like to do is combine them, also known as concatenation. So let's say we had a first name and a last name that we were stored separately. So in the example, it says to say John and Doe, but I'll use my own name. I can say whatever you want. We'll set two variables, first underscore name equals, and I'll say Sarah. So I'll make sure I put that in double quotes and I make sure I close the double quotes. Next line, I'll do last underscore name equals double quotes Clark. And so instead of having these first and last names being separate, I want to combine them into one variable to just be the full name. So what I can do is I can concatenate them by placing them side by side with a plus sign between them. So I can set a variable now, full underscore name equals, and we can kind of do math with the strings. So the first underscore name plus last underscore name. And even though these variables are going to give us strings, we don't have to enclose them in double quotes because we're calling the variable name. We're not typing the string directly in our little addition that we're doing here. So I can try full name equals first underscore name plus last underscore name, and now I'll try calling full name, and we'll see. Now I can shift enter, and it did concatenate them exactly how I told it to. So technically it's correct, but that's not quite what I wanted here because it didn't add a space in between. I have to tell Python to add a space in between. So I'll come back into this cell, and in between the first name plus last name, we'll add a string that just has an empty space. So now we have first underscore name plus double quotes around a single space plus last underscore name. Now, if I rerun this cell, it should fix it for me. Wonderful. So I can use these variables as well to write a print statement involving string variables. So I could use f-string formatting, which feels fairly natural and is less awkward to type without separating strings and variables with commas. So what I'll do is from this cell here, I want to add a new cell underneath. So I can find this symbol here, the square with the plus, or the rectangle with the plus underneath. And that'll get me a new code cell. So I want to type a print statement. just because we'll be using these a lot later. So we type print, start the left parentheses, and to write it without the F string first, we add our string in double quotes still, my name is, end that double quote, comma, and now the variables that we want to call. First underscore name, comma, space, last underscore name. And then we have to end our parentheses. And if I shift enter here, it should print, my name is Sarah Clark. And it does. So another way to format this string, just so that you see it before we get too far down in this workshop, we can try print again. Left bracket, and now we type F, and then we start our string. So I'll write the same thing. My name is, and instead with this F formatting, if we want to insert a variable into our string, we can use curly braces. First underscore name, and we write our sentence quote unquote normally. First underscore name. So first underscore name, space, last underscore name, and both of those are enclosed in the curly brackets. My string, close that print function. And now if I hit enter again, now this should print the same thing. So now I should have it twice. And I do. Yeah, with this way of formatting the print statements, the spaces get added automatically when it's separated by commas, or if you're doing print functions. I could get rid of the spaces here. I prefer the printf formatting because you kind of write it exactly how you would want to write it. And you don't have to worry about the commas and where the spaces are. Wherever you add spaces in printf formatting, it'll print correctly for you. And the curly brackets are to indicate that this is a variable name. If I got rid of the curly brackets here, say around first name, now it's part of the string and it's not asking for the value of that first underscore name. And yeah, the F here just indicates that this is a specific string format. So if you want to use curly brackets to substitute variables, you have to add this F here. There's lots of different ways to format strings, but these are the two nicest ones. Another thing you can do with strings is repeat them. So for instance, if you had the word hello, you could repeat it multiple times. I can try that in here. I can try echo, which works really similar to print. Well, no, sorry. I'm thinking of the bash command. We'll set echo as a variable. Echo equals. And now we'll start a string that's hello, and we'll add a space. Multiplied by 3. So hello, asterisk 3, and we'll call that echo variable, and it should print hello, hello, hello for us. Shift enter. There we go. And you can see the output string is in single quotes here. And the last thing in the string is a space. So once again, everybody's still with me. We'll get a green check. Maybe. Okay, no, we'll keep going a little bit and then we'll take a quick break. And yeah, this echo, this is a variable name that we set. It's not a specific function. So next thing we'll do, we'll talk more about Booleans. So Booleans in Python can represent only they only have two options for the values. They could either be true or they could be false. And they're most useful when you're asking questions or checking if something meets certain conditions, like when we were checking if a height was tall enough. So let's say again, we wanted to check if a measurement is above a certain number. Say we use our population measurement again. Under here, I'll just call that population variable quickly just to check. Population, shift enter, and we still see it's 20,000. So we can continue to work with this population variable. So what we want to do, I'll backspace this because I don't want to call it again. We want to check if our population of our imaginary town, we want to see if it's a large town. So we'll get a variable is underscore large underscore town. And we want to check if population is greater than 10,000. So now we use our population variable. We're checking if population is greater than 10,000. All that is large town variable. And because we know the population is 20,000, sorry, we are expecting that this is going to say that it's true. So I could shift enter, and it is indeed true. The population is greater than 10,000, so it's a large town. We could also ask Python to check multiple conditions at once. So maybe you want to know if the town both has a large population and a low unemployment rate, so say under 5%. We can combine these two questions into one, and then if both are true, Python can tell you true. If one or both are false, Python will tell you false. So let's try an example. So we already have, we'll go here, we'll type is underscore large equals, so our condition for if the population is large is if the population is greater than 10,000. We also want to check our unemployment rate. So the unemployment rate for this town, we'll set it unemployment underscore rate equals, we'll say 7. And I'll add a comment here. This is in percent. Space these out a little. And then the question we need to ask to check if is underscore low underscore unemployment is if the unemployment rate underscore rate is less than 5 or 5%. Times just to space that out. Now we want to check if the population is large and there's a low unemployment rate. So we'll ask is large is underscore large underscore and underscore stable equals. And so now we're asking for the values of both of these. So is underscore large and you'll notice the formatting changes because Python will recognize that and means something specific. Is large and is low unemployment. And so now what we want to do is check the value of this variable here. So we're asking, is the population both large and does it have a low unemployment rate? So if this, when we call this variable, I'll wait a second to actually run this cell and call it. get ready to call that variable. And so we know that the population should be large. So this one here, we know the population is 20,000. That is greater than 10,000. So we're expecting this to be true. Asking if there's a low unemployment rate, that means the unemployment rate is less than 5, but we know the unemployment rate is 7, which is not less than 5. So if it is large and is low unemployment, if both of these are true, then it will evaluate to true. If one or both of them is false, then it will evaluate to false. So we know this one is false. So we should expect that this is large and stable variable is going to tell us that it's false. So I can run that. And there we go. It says it's false. So that did follow what I expected. So it was 20,000 people, employment rate of 7%. It didn't meet all of the criteria, so the overall statement's false. And so the last thing we'll do before we take a quick break is we'll talk about how to mix types together. So sometimes Python lets us mix types in ways that make sense. So for example, in Python, a value of true means that it has a numerical value of 1 that gets assigned, and a false would get a 0. So if you're working with, you can work with Booleans and numbers together fairly easily. So if we go in here, Python could do something. If you're working in Python, you could do things like add a 1 if something's true, or leave it the same if it's false. So we can type adjusted underscore pop, short for population, equals population plus is underscore large. And so this is our same is large variable from before. So this we know is a value of 20,000. This we know is a Boolean that should evaluate to true. Enter. So now if we call this adjusted underscore pop variable, we should get a number. Shift, enter. And we do indeed. And it's 20,000 plus 1, because a value of true has a numerical value of 1. I could try this again. I could go back in here and I could change this to be is low unemployment. This one here. Then when I run this, I know that the is low unemployment should be false. So the pop, this adjusted pop should still be 20,000. And that is indeed what happens. And so with just these few operations, they allow you to do quite a bit in Python. So with strings, you can write descriptive phrases. With numbers, you can add, multiply, and do more complex math. With Booleans, you can check conditions and you're able to make decisions, or let Python make decisions for you. This flexibility is what makes Python both powerful and beginner friendly. It's fairly straightforward to write code that mimics kind of real world problem solving. So now I think what we'll do is we'll take a quick, I guess, a 10-minute break.
Yeah, 10 minutes sounds good.
I have no idea what time it is in Pacific time. I can't do that. It must be
Just add
10,
10 minutes to whatever time.
26. Okay,
Sounds
it's
good.
2:26 for me.
Okay, 10:26.
Okay, yes.
Yeah.
Perfect. Thank you to the people telling me what time it is.
10:36, we'll be back then. Okay, I'll pause.
Perfect. Yeah, if everyone could just give me a green check and make sure if you're back from your break. One thing that I'll show you as we come back is how to save your notebook so you don't lose it afterwards. So there's a couple different ways to do that. I can hit this floppy disk symbol here. That's up just underneath the tab menu. I can hit that and you can see down here it says saving completed. Oh, now it's gone. I can also go File, Save Notebook, or you can do Control S. So it's good to do that every now and again and make sure you don't lose what you're working on. So and everybody to save before the end of the session as well. So the next thing we can do is we can talk about data structures. So I'll scroll down a bit. And lots of good questions in the chat too, by the way. I think they've all been answered. I had a scroll during the break. And so data structures are essential for organizing and managing data in programming. And these exist in other programming languages as well. So in Python, we have several types of data structures, but three of the most commonly used ones, we have lists, tuples, and dictionaries. And I say tuple, I think some people say tuple. I'm locked into saying tuple now. I can't hear it in my head any other way. Each of these has unique characteristics and use cases that make them suitable for different tasks. So the first one we'll talk about is lists. And so in Python, this is a collection of items that can be modified. So this means that we can add, remove, or change items in a list as needed. And so we can define lists using square brackets. So in this code block here, I can go grades. We'll set a variable grades to be a list. And so I'll put my square brackets there and I'll complete the brackets first and then use the arrow key to go into the square brackets. And that helps me not forget to close my square brackets because just like the double quotes, it's easy to forget to close a parenthesis somewhere. So I'll start my list. So the first item in my list of grades, I'll do 85.5. And to set your list, to separate the items in the list, you separate them with commas. So 85.5, comma, and I'll add a space. Once again, the space isn't specifically necessary here, but it helps you be able to read it. So I will use spacing like I would with commas if I were writing words in English. 90.2 will be my next item, comma, 78.0, comma, space 88.5. Hit enter, and I can call that grades variable, shift, enter, and it should print my list. And so we can say that this list of grades, we can imagine it stores test scores from different students. They did a decent job. So now we can talk about what we can actually do with the list. So the first thing is about accessing lists. So say we want to access and do a calculation on one specific item in a list. So each item in a list has a position called an index starting from 0. And so you can access any item using its index. So in this grades example, the first item in this list has an index of 0. Next, index 1. Next, after that, index 2, and so on and so forth. So here we want to print the third item in that list. Or actually, no, we'll get the first one. So we'll write first underscore grade. Ooh, it just started. First underscore grade equals grades. And we want to specify the index, and we'll do that in square brackets that are right after grade. So there's no space between our list name and the square brackets here. We'll just type 0 in those square brackets, and that'll tell me it wants the thing from index 0, which should be the first item. So I can call this variable first underscore grade, shift enter, and we do indeed get 85.5, which we know is the first thing in this grades list. So next thing is modifying items. So we can edit a list entry by, again, specifying the index of the item that we want to edit. So like I mentioned before, lists are mutable, which means that you can change their contents. So if I go in here and I want to edit item number 3 in grades, so that would be an index of 2. No, I got that mixed. Item number, don't would. Index of 2 would be item number 3. Sorry about that. Okay, so we go grades, square brackets. And the square brackets, there's no space in between the square brackets and grades. We want to edit the item with the index 2 equals, and we want to set that to 93.0. Enter. And now let's just call the entire list and we'll see what changed. Shift enter. And yes, this time now we've updated our grades list. And so that third item that has an index of 2 is now 93.0 instead of 78.0. So I guess the student redid the test and studied hard. Now let's say we want to add a new item to the end of this list. A new student completed the test, so we have to add their grade to the list. We can do that using the append method. So in this block here, I can type grades, and now we do dot append. And now in regular parentheses, we can input the value of the grade we're adding to our list. So grades, whatever our list name is that we want to append to, dot append, parentheses, and we'll say 65.0. And now we'll call our grades list again. And now this time we should have 5 things in our list instead of 4. Shift enter. And there we go. It's the same list as when we edited the 93, but this time we have 65.0 tacked on to the end. Yeah, everything we've done so far has been with like base Python. We haven't worked with any external libraries or modules. Tanya will talk about those a little bit tomorrow. So another thing you can do with lists is you can remove items from the list. So that last student got transferred out of the class. We don't need to record their grade anymore. We can remove items from a list using the remove method or the pop method. So we can try both here. So we can try grades dot remove, and then we can specify the value that we want to get rid of in regular parentheses. So we want to get rid of that 65. 65.0. Call that grades list. And this time we should go back to what we had here because we're removing 65. Shift enter. There we go. Another method we can use pop and specify the index that we want to remove. So I can try grades dot pop, pop, and then in regular parentheses, we'll put index 2. We can call that grades, shift, enter. And this time we've removed the third item from our list, which has an index of 2. So here, we saw some of the things that we can do working with lists, and soon we'll get to more ways to make this even more efficient and automatic. So everybody's still with me up to now. I still see questions in the chat, but I think they're all getting answered. Scroll fast too far. So the next data type that we have are tuples. So a tuple is a collection of items similar to a list, but it is immutable. So once a tuple is created, it cannot be changed. And so tuples are defined very similarly to lists, but they use parentheses instead of square brackets. So we can try one. We can set a tuple. We'll say coordinates equals, and now we'll use regular old parentheses, 47.5, comma, negative 52.3. Enter, and we'll call that, just to print it out, coordinates, shift, enter. And so here we have our tuple printed out, and this represents the geographic coordinates of a specific location. I did look up where this was because I was curious, and it's off the coast of Newfoundland in the ocean somewhere. And so just like lists, you can access items in a tuple using their index. So say we wanted, here we can say we wanted the latitude, which I guess is the first item in our list of coordinates. Get latitude equals coordinates. And like when we were using the index with lists, we can use square brackets here to specify the index. So coordinates and no space between coordinates and the square brackets. And we want the first item, so it's index 0. And we can call that latitude variable. Shift, enter. And we get a value of 47.5. Now what I want to do is I want to try and change, just for demonstration's sake, we'll try and change that first item, the 0th item of the coordinates, and update it to be 48.5 instead of 47. Let's try in a similar way to how we update lists. Go coordinates, square bracket, 0, because I want to edit index 1 equals 48.5. Now, I'm not expecting this to work. We'll see. Shift enter. And Python tells me, nope, you can't do that, which is what I expected because tuples can't be changed. And it tells me type error. Tuple object does not support item assignment. So once you set a tuple, you can't edit it. There are benefits for this. You might be thinking, well, what's the point in using a tuple over a list if I want to edit things? There are cases that you'll encounter where you don't specifically want to be able to edit things. So they're useful for storing fixed data that should not be altered. And so like this can help you prevent accidental changes to important values. So I don't know, I think in this example, it comes from oceanography with the coordinates. You might want to store the coordinates of a specific research station. So since these coordinates are fixed, I just lost my place. Since these coordinates are fixed, you don't want to, they won't ever change. So a tuple or a tuple would be the ideal choice. Then if you need to reference these coordinates later in your code, you can do so confidently and knowing that you're not going to accidentally change them. And then I think eventually if you work in really parallel code, I mean, anything you store as a tuple could be stored as a list, but it is faster to use tuples. Scroll down a bit. And I see a question there. I think the square bracket is generally if you're going to be using the index of your list or tuple. When it comes to referencing things here. So the last thing we'll talk about, well, no, not the last thing, I'm lying. The next thing we'll talk about, dictionaries. This is the last data structure we'll talk about, is a dictionary. So a dictionary in Python is a collection of key value pairs, similar to how in an actual dictionary, we have the words, which are the keys, and then their meanings, which are the values. So each key in a dictionary must be unique, and you can use it to access its corresponding value. And so dictionaries are defined using curly braces. So let us make one. So to start off, we'll call this student underscore data equals, and now I'll begin my curly braces, but what I'll do is I'll go in the middle of them and hit enter a couple times just to give myself some space. Enter once. So I should be indented one level here. That's what I want. So now what I can do is I can start typing out the things in the key value pairs. So to set the key, I go in double quotes, name, and then right after that, I use a colon, space, and I type in the name in my sample dictionary. So I have my key, colon, and then my value. So after that, comma, enter. And you'll notice I should stay indented here. This is what I want. My next key is age, colon, and the value, 20, comma, enter. Next key, grade, double quotes, colon, my value, 88.5, comma, enter. Chat is moving quickly. I'll keep going. And the last thing I want to put in this student data dictionary is the major. So my key, major, colon, and then the value, computer science, let's say. My dictionary curly brace is already closed. I have it down here. So outside of that, I'll hit enter a couple times, and I want to call this dictionary. And I'll give you a second to catch up because that's a lot of typing. Run this and it should print. So I have name, Alex Johnson, age, 20, grade, 88.5, major, computer science. Can you give me a green check mark once you have that dictionary and you're able to run it and it prints out nicely? Okay, perfect. You're getting a bunch. Awesome. So in this example, we have a dictionary called student data that stores various pieces of information about a student's academic details. And so just like with lists and tuples, we can access the values, we can modify the values. We'll go through now how to do some of those things. So maybe what I'll do is I'll just copy this into the chat just in case. So in case you're still catching up, I will carry on. So accessing values, that's the first one. You can retrieve a value using its corresponding key. So let's say I want to get the current grade equals. Now what we want is we want the grade item out of this student data dictionary. So student underscore data, square brackets here, and we specify the key that we want, grade. Now, if we call this current underscore grade variable, typo, current underscore grade, shift enter, it should tell me the grade is 88.5, which is what we set in student data. We could also modify existing values. So the first thing we'll try is we'll modify a value that's already there. So what we want to do, let's edit the grade. So similar to when we were editing a list item, We can type student underscore data because that's the dictionary we want to edit. And the key pair that we want to edit is the grade one. So student data, and then square brackets, we type our key in double quotes, grade equals 92.0. So we're updating his grade from 88.5 to 92.0. Now, if we call this student underscore data dictionary again, it should be updated. Shift, enter. There we go. Name is the same, age is the same, grade has been updated, major is the same. Perfect, that's what we wanted. Now what we can do is we can add a new key value pair because let's say we want to include the student's attendance data. So student, oops, not make that complete. STDE, student underscore data, square brackets, double quotes so we can type in our key name. So we want to add attendance equals 95. And you'll notice this syntax here for updating the grade and this syntax here for adding a new key is the exact same. We have the dictionary name in square brackets, the key, and then the value we're assigning. Essentially, once you run this, Python will know that the student, it will check student data and it'll be able to tell that, oh, this one doesn't already exist. This attendance key pair doesn't already exist, so it'll get added. Enter. Now we can call this student data. And this time we should have another, there we go. Yeah, so after the major, it added attendance. And he has 95% attendance, I guess. So if this attendance value already, or if this attendance key, sorry, was already in the dictionary, you'd be editing that entry instead of adding a new one. So it's just something to be mindful of. Another thing we can do with dictionaries is you can remove a key value pair using the del statement, short for delete. Space. And let's say we don't care about the major anymore. That's changes, people change their mind too often. We're not going to track it right now. Student underscore, that's not an underscore, student underscore data, square brackets, and the one that we want to delete, the key is major. We can call that variable again. So we can print our dictionary. So del space student underscore data, and then that same syntax, square brackets with the key in double quotes, shift enter. And now we have the name, age, grade, and attendance. So what we want to do now is we can expand this dictionary to include more details by combining dictionaries and lists. So we could represent multiple subjects with their scores and attendance records to get a more detailed view of this student's academic performance. And so this is where the flexibility of Python really comes in. So we'll start a new dictionary where one of the entries is actually a list of dictionaries. So this one will be a lot of typing. So we'll go student underscore data underscore extension equals. And now let's see, best way. I'll start my main curly braces and hit enter once. So the first thing in this dictionary will still have the name. So double quotes, name, colon. And then the value for that key. It'd still be Alex Johnson, end quote. Comma, underscore, not underscore, comma, enter. Next will be the subjects. And so the next key subjects, and close that in the double quotes, colon. And so now what we want to do is we want to start, the value of this subjects key is going to be a list of dictionaries. So to start a list, we do our square brackets. And now for the sake of clean formatting, I'll do my square brackets, move my cursor so it's in between them, and hit enter. And now you'll notice I'm indented again. My cursor is. That's good. That's what I want. And so now I start my dictionary. The dictionary that is an item of a list within a dictionary. So I'll do my curly brackets and I'll start my dictionary. And the first key is subject, colon, and the value is math. And that, comma. Next thing in this dictionary, the next key will be score. And that double quote, colon, 85.0, comma, because dictionary entries are separated by commas. This time I'm doing it all on one line. Next key, the last key for this one, can't spell, attendance. Double quote, colon, 90. And so subdictionary number one, done. Now, outside of that subdictionary, because this is a subdictionary within a list, comma, enter. And now, okay, what I think will be easiest here is I can highlight this and copy and paste a little. I'll bring my cursor back down. Copy paste this, and now I can edit these values because the subject, score, and attendance keys are going to be the same. I just want to change these values. So here I'll type English instead of math. The score, I want that to be 88.5. Attendance, I want to be 95, and I make sure outside of this, because this is still a dictionary within a list, comma, to separate from my next dictionary. And I should still have that copied. So if I can again, yes, and I get that same structure. This time we'll say science. So the score for science will have 92.0, and attendance will be 85. And so this time I don't need a comma again because this is the last item in the list. So the nice thing about the Jupyter notebook here is if your cursor is right next to an end brace, it'll highlight the end and the beginning so you can tell. So my list is fully enclosed and my big dictionary is also fully enclosed. Yes, and I'll copy and paste this full one into the chat. I see someone asking for that. Here we go. The formatting might be wonky, but it should copy okay. So here we have a well-organized way to store information about this imaginary student's academic performance using a dictionary that has a list of dictionaries inside. So the two main dictionary keys are the name and the subjects. And then each subject has details like the score and the attendance and whatever else we might want to add. And so this structure, dictionaries in general, they're beneficial because they keep related information together and makes it easy to find and update data. So the use of a list allows for multiple subjects to be stored in order, while each subject's details are kept in their own dictionary. So, I mean, we could just have a list of scores, but then there's no way of associating that with the specific class that it's from. And all of the attendance and grade numbers are just random numbers in a list. You want things to be organized. And so the combination of lists and dictionaries makes it simple to manage complex data sets, and it reflects just how we naturally group information in real life. Like, it wouldn't make sense just to keep a bunch of random lists around with no indication of who those scores belong to or what class they're from. So I'll make sure I run this. I'll run this cell. I'll also call it just so we can look at it when it prints out by Python. Student data extension, shift enter, and there we go. It prints. That's what we expected. So scroll down a bit so we can carry on. And okay, yeah, we have about 20 minutes left. Whatever we don't finish from this notebook, Tanya will carry on tomorrow from wherever we leave off today. So, similar to lists and tuples, we can access the specific entries in dictionaries and the sublist within the dictionaries. So, if we want to get the name from our main dictionary, we can get name equals student underscore data underscore extension, square brackets, double quotes, name, because that is the key here that we had set. Now, if I call the variable name, shift enter, it should print, yep, Alex Johnson. And now we want to access data from the subjects list. So the subjects key points to a list of subject dictionaries. So if we want to access this, let's type subjects equals, same way as we just did, student underscore data underscore extension, square brackets. This time we want the value of the subjects key, which should be a list of 3 dictionaries. Now we can call that subjects, shift enter. There we go. We have our list, and we can see it's a list. It's enclosed in square brackets that has each item is a dictionary that's enclosed in curly brackets. Lots of brackets going on. We can also get a specific entry from that list of dictionaries. So each subject in the list can be accessed using its index, so its position in the list. And then again, just reminder that Python uses zero-based indexing. So the first thing in the list is index 0. So we want information on just the first subject. Equals student data extension, square bracket. The first bit, we need to tell it it's in the key subjects. And then right after that, another set of square brackets, 0, because we want the 0th, we want the 0 index item of subjects. Enter, we can try running first underscore subject, shift enter, and it should just give us the first item in our subjects list. And we do indeed. So we can go even further. We can continue on and we can get a specific item from this sub-dictionary. So say we want to get the score from the second subject. We can start second underscore subject underscore score equals student data extension square bracket subjects. We're essentially giving Python instructions on each step to get further into our data structure. So the first thing, we want subjects, and then we want the second item in the subjects list, and we want specifically the score. So I'll scroll back down to where I was typing subjects. We want the second subject, so that should be index 1 in square brackets, and then Right after that, square brackets again. This time we give the key score. Now we can call that variable second underscore subject underscore score. Shift enter. There we go. So yes, by using the keys to reach the specific pieces of information that you need, you can get any piece of data from the dictionary and its contents, sorry. You start with the top level keys and you get more and more specific until you're getting the output that you want. So there's another here if you want the attendance of the third subject. We can do this one quickly. Third underscore subject underscore attendance equals student underscore data underscore extension square bracket. We keep getting this from the subjects. This time we want the third subject, so index 2 in square brackets. And we want the attendance. And so now we can call that variable third subject attendance. Shift enter. Still with me. Okay, how would we access the student grade for the math subject? We have to check if we wanted the score of the math subject. We would want the first subject. I can do it right here with this access specific data in a subject. We want the subjects. Math is the first subject, so we'd have to change this index to 0. And it would give us the score. And the score for math is 85. I'll change this back just so it's actually reflective of getting the score there that I said it would. All right. So we can talk a little bit about how to choose the right data structure. So selecting the appropriate data structure is pretty crucial. So generally, use lists when you want to store a collection of items that you might want to change or add to, like we talked about grades over multiple subjects, keeping track of assignments. This is generally for raw data that you might be collecting on a regular basis, that sort of thing, things that can change. Tuples are generally for, well, not generally, they are for fixed data points that won't change, like geographic coordinates we mentioned, constants you might need in calculations. There's plenty of reasons in many different fields why you might want to use a tuple. And then dictionaries are most useful when you want to keep or associate related information together, such as like we did all the academic details for a specific student. Maybe you're a biologist studying animals and you need to keep track of the, what is it, genus, phylum, class. It's been so long, I don't remember any of the others. You know what I'm talking about. Choosing the right data structure will make your data management more efficient and your code easier to understand. And so there is a little exercise here on choosing data structures. We will skip it for now in the interest of time, but Tanya can share, you can try it before tomorrow and we can share the solution with you tomorrow. It's the question about how to set up a data structure or what would be the best data structures to use to organize this data here. So the next thing we will talk about that will start today are control structures. So this is when it really gets fun. So control structures are essential programming constructs that allow us to dictate the flow of our program. So in Python, the most commonly used control structures include loops, so for loops or while loops, and conditionals, so things like if and else statements. And so these structures enable us to repeat actions, make decisions based on actions, or make decisions based on conditions, sorry, and manage how we process data. So the first one are conditionals. So they allow us to execute certain blocks of code based on a specific condition. So we already talked about conditions a little bit, but we'll see some more. So this means that our program can make decisions and act differently depending on a different situation. So the most common conditional statements in Python are if, elif for else if, and else. So here we have a basic structure for conditions. So first is if condition. And so this condition would be checking if something is equal to something, not equal to, greater than, less than. We see a few comparison operators down here. I'll go over them in a second. So if condition, and so if this condition is true, then we have indented here code to execute if the condition is true. Next, we have else if, another condition that we can specify. And then there's code to execute if this first condition is false, but this one is true. And then we also have else. And then here we have code to execute if both of the previous conditions are false. And you can make really long if statements. You can have if something, else if, else if, else if, over and over again. If you have lots of conditions to check for, it's really flexible. And so it can be used in a lot of different ways. The comparison operators allow us to compare two values, and we kind of looked at these already when we were talking about Booleans. So some of the most common comparison operators in Python is equals to, which is two equal signs, because just using one equal sign means you're setting a variable, usually. Checks if two values are the same. Exclamation point equal sign, not equal to, checks if two values are different, greater than, less than, greater than or equal to, and also less than or equal to. We've all learned these in math class at some point. So let's do an example and say we want to categorize towns based on their population size. So we'll bring back, I'll set my population variable again. I don't think I actually need to, but just so that everything is contained in this cell. So when we're looking at it, it makes sense. Population equals 20,000, still the same value. Now, we want to categorize whether it's a large town or a small town. So we have population equals 2,000. We'll start our if statement. We'll say if population is less than 5,000, colon, enter. And so now you'll notice that my cursor is indented. That is what you want, and that is what Python needs. The indentation for the structure of these conditionals is mandatory. So now we write what we want the code to do if the population is less than 5,000. So we can type print. I want to print that this is a small town. So print, I'll finish my regular brackets, double quotes, print small town. Now, enter. So now when I hit enter after this print statement, I'm still indented. If I want to continue and add another condition, I have to go outside of. If I want to add another condition, I can backspace once and that should bring my indentation back. You can do conditionals within conditionals, but right now we don't want to do that. So if population is less than 5,000, print small town. Now, our next part of this, ELIF, so else if. Now we want to see if the population is between 5,000 and 20,000 inclusive. So 5,000 less than equal to population less than equal to That is 20,000. So we're checking if the population is between these two values. Colon, enter. Now we're indented again. We can print that it's a medium-sized town. So I'll make sure that's appropriately formatted in the round brackets and double quotes. Medium-sized town. We'll get out of those brackets and hit enter. Now it still wants me to be indented, but I don't want to continue in that code block. Next, I'll type else, because if it doesn't meet either of these two conditions, then that means it must be larger. So else, colon, and then enter. Notice I'm indented again. I can print in my brackets and double quotes, large town. So now if I run this, I would expect that it's a medium-sized town because population is 20,000 and this else if block here, this is less than or equal to 20,000. So I can go shift enter to run this. And it does tell me that it is a medium-sized town. So yes, population is less than 5,000, it would print small town. So this condition, false. So it moves on to the next one. Else if it's between 5,000 and 20,000, it prints medium-sized town, which is what happened. If neither of these were true, then it would print large town. So let's say it's add a 0 in here. So this is population is now 200,000. I can rerun this loop. And now it's telling me it's a large town. I can edit this population variable again. This time it's just 3,000. It will run through the conditions in order. And the first one that is true, it will execute the code block that's underneath it. Shift enter here. This time I set my population to 3,000. It's a small town. All of them do have the colon. It's at the end of the condition because else doesn't require a condition because else is for if none of the previous conditions are true. So there is a colon at the end of these. This is that's another really easy thing to miss when writing these. The number of times I've forgotten a colon while trying to do something and then losing my mind trying to find what I did wrong. And it's a colon or an end parentheses missing somewhere. Terrible. All right, so, oh, you know what? I've reached the end, pretty much perfect timing. So the last thing we'll talk about is logical operators, which we did see a little bit already when we talked about Booleans. And so these allow us to combine multiple conditions. So the most commonly used logical operators are and, or not. So and will return true if both of the conditions are true, or returns true if at least one of them is true, and then not reverses whatever that truth value is. So it makes true become false or false become true. So let's say if we wanted to see if someone's annual income fell within the middle income bracket. Let's say annual underscore income equals 45,000. Yes, that's enough zeros. Enter. Now we can say if annual underscore income was greater than or equal to 30,000 and annual income was less than or equal to 70,000. 70. There we go. I should put a space in between here. Colon, because we always finish these if, elif, and else was with a colon. We can print parentheses, double quotes, but they are in the middle income bracket. I'll go outside of that, down, backspace, because I don't want to be in that if statement block anymore, and then else, colon, we can print in double quotes again, format our string, outside, middle income bracket. And just looking at the numbers, 45,000 is indeed between 30 and 70,000. So we can expect that this condition should be true because it is both greater than 30,000 and less than 70,000, and it should print that it's the middle income bracket. Shift Enter. And it did indeed. Awesome. So yes, we arrived at the end of the day one notebook with perfect timing, I think. So I don't think I have anything else to mention before next class. We'll be using the day two notebook, and Tanya will be teaching you through that, which will be probably more exciting than what we did today. But thank you everybody for coming and asking lots of questions. And also thank you to the helpers for answering them all excellently.